now that I've introduced the rules and the new semantics, and I've alerted you to the notion of the importance of implementing things in the right order, let's try to make side effects a bit more explicit in the notation. So that is absolutely crystal clear that you should implement things from left to right. So first thing we could do is let's just make the triangles represent the order. So it's a way of sequencing. When you're implementing this, it means that first you should implement this and evaluate this, and then you should evaluate this, right? First this, and then this. First this, and then this, and then that, and then finally this, okay? So you could think of this as a way to order the conditions that are above each rule, okay? Another thing we can do is we could even annotate the heap, because what we are going to do is we're going to use a heap to represent mutation. So implicitly what exists in these rules is a global heap that is being mutated somehow. So let's make that explicit in the rules and understand what's going on. So the idea is, again, we are implementing mutation in a language that is side effect free. So that means whenever we mutate something, we need to create a copy of it. So how should we interpret this rule? This rule is for define, and what we're saying is define is the input. So whenever I'm evaluating a language lambda e, I actually have three parameters. The first parameter is a heap, which is the initial heap of my program. So in this example, it's basically a heap that has the enclosing environment E0 that is initialized to empty. So that's what H is supposed to be. And then what do? I evaluate, the second parameter is the expression that I'm evaluating. In this case is define. So let's say I'm doing this define. Okay, next what I do, let's look at the line above. So the line above is saying that I start with this arrow is saying is basically annotating the side effects in the heap. So I start with my heap H, right? And if I evaluate this expression, right, which is E, the body, if I evaluate that recursively, that could mutate the heap somehow. And let's say that that mutation is apparent in heap H1. Okay? So evaluating an expression down to a value could potentially update my heap. So therefore, it should return a new heap, and I need to keep it somewhere. So basically what that says is when I evaluate something, I no longer have two values, right? What I actually have, I no longer have just the value as an output. I actually should have two things. I should return, so let's look back down in this arrow. What I'm saying is that when I evaluate this, I have three inputs, right? Three parameters. First one is the heap that is implicit. That was implicit in the previous rules, but now explicit. So first parameter, heap, global heap. Second, expression. Third, what is the current environment? And this is a reference to the environment, right? What should I return? Look, that we are returning two things. We have a value and the final heap. So how do we evaluate this again? We take the original heap given by input, given in the parameter. We pass it to recursively evaluate the V. As we know, it should return two things. So the value and the new heap. So this is the new heap H1, and I'm going to use that new heap in H1 to update my heap, right? I'm going to do a put operation in H1. So H1 is also a parameter of this operation. And what does that output? After I update, so after I do a put, I get a new heap, which I finally return. Okay, so this is the difference. So finally, if I update my rules, I see this is happening. Okay, so I see that actually these rules, they are side effects free, these three. But I do see that my eApp actually updates the heap because it has these little triangles. So I see that here I could potentially update that, mutate the heap.